Hello, ladies and gentlemen. This is Mr. Arias again. Welcome back to my channel. In this video, I'm going to keep talking about this type of multiplication that I explained in the previous video. If you haven't watched it, please watch it. And this time, I'm actually going to call it the box method. I used to call it the common core way, but now I'm going to be more specific because we're basically using this concept of a rectangle or a box that will help us visualize the multiplication problem that we have here on the screen. So we have to multiply the following expressions: 3x plus 2 times 2x plus 1. And what's going to happen here is that we are going to be aligning these expressions along the base or the height of my rectangle. So you basically have to choose which parentheses, which expression will be at the top along the base of the rectangle, and which one will be along the height, which is the vertical side of this rectangle. So in this case, I'm going to choose 3x plus 2 to be on the top, and then 2x plus 1 to be at the bottom here. Well, it's kind of on the side, on the left-hand side, actually. And then I'm going to begin multiplying. And what's going to happen is that I'm going to end up multiplying each term from the height, from this vertical side, 2x plus 1, by each term from the base, which is this top section that has the expression 3x plus 2. And then eventually, that's going to create the following entries inside my rectangle. And the last step will be to add them up, and that will be my answer. So let's begin. So I'll begin multiplying 2x times 3x. So I'm going to begin multiplying the first term on my height by the first term on my base, and that will be the top left entry that we get in the rectangle. Then after that, we'll multiply the same 2x, but now by the positive 2 that is here at the top. And that will be the second entry of my rectangle. Now that I multiplied each term from the base by my 2x, now the next thing will be to multiply this one from the height by the same terms that we have at the top of this rectangle. And that will create the entries that we have in the bottom section of this shape. So that's 1 times 3x, and then the last one will be 1 times 2. Okay? Then after simplifying, if you multiply 2x times 3x, that is 6x to the power of 2. You combine the exponents that are 1 at the top of these variables. 1 plus 1 is 2. And then for the second entry, if you multiply 2x times 2, that is 4x, we just multiply the coefficients and we attach the variable. For the third entry, we're multiplying 1 times 3x, which is just the same thing, 3x. And for the last one, we have this easy multiplication of integers, which is 1 times 2, and the answer is 2. So lastly, the last thing we have to do in this case is to compute the area of this rectangle. And what that means is that we have to add up all the terms that we obtained after multiplying all these terms that appeared on the base and the height. So I'm going to end up adding 6x to the power of 2 plus this positive 4x, and then plus the 3x from this third section in the rectangle. And the last element that we have is this positive 2. Okay? Then from here, I'm hoping that you're noticing that we have a few like terms that we can combine. And those happen to be 4x and 3x. These are going to be like terms. Like terms, which means I can add them or subtract them. But this time we're going to be adding them because we have a positive 4x and a positive 3x. Okay, so when you add them up, that's a positive 7x. And because the 2 and the 6x to the power of 2 do not have any other like terms, we can't possibly combine them with anything else on this expression. The final answer, ladies and gentlemen, is this trinomial or algebraic expression, which is 6x to the power of 2 plus 7x plus 2. Okay, so if you check this multiplication problem with any other method or with any graphing calculator or any other type of device, you'll see that this is exactly the answer that we get for this problem. Now, why would I recommend this technique? To be honest with you, I like this technique because it's really visual. I can see what's happening, and it's really straightforward to see how the multiplication takes place inside this rectangle. And instead, other techniques might rely on memorization, which is, hey, here's the acronym, memorize it, and then eventually apply the steps one at a time. So the main idea that I think is important in today's courses in the US is that we're teaching not to rely too much on memorization, and instead to apply steps that are more visual and easy to understand. Now, this is a technique that applies to integers, algebraic expressions, and more complicated terms. And that's going to be the next example that we're going to be working on here today. So now I'm going to be doing the following. I'll quickly clear this, and I'm going to show you how you can even multiply something more complicated than this two parentheses that we have on this problem. So I'm going to quickly change this expression to the following. So I'm going to kind of leave it the same. However, I'm going to create an expression that has 3 terms. Okay, and then I'll do the same thing for the other one. Let's do 3x to the power of, let's make it complicated, power 3 plus 1x minus 5. Okay, so Mr. Arias, what if we have this crazy problem in which we have to multiply these more complex and more challenging algebraic expressions? That's perfectly fine, ladies and gentlemen. This technique will be perfectly fine. The only modification that you have to make on this rectangle is that because now we have 3 terms in each parenthesis, we are going to be creating another section on the right-hand side, because you can technically say that each box corresponds to each term that we have along the base and along the height. So that being said, I will need another row. I'm going to say below, so that I can align my other algebraic expression along the height of this rectangle. Okay, so in the previous example, we were multiplying 2 binomials. That was a 2 by 2 rectangle for entries inside the area. Now, because we're multiplying 3 terms by 3 terms, in this parentheses, the dimension of my rectangle will be a 3 by 3 rectangle. So we have pretty much 9 entries inside this area. So now let's get into it, and I'm going to prove it to you that this method works here on these examples as well. So let's begin. I'm going to multiply 2x. So I'm going to choose this first parentheses to be the base, 2x plus 2x. Remember, each term per box underneath the expression. And then plus 3. And then for the height, I'm going to be choosing my second parentheses, which is 3x to the power of 3, plus a positive x. And then I'm going to use this plus just for separation purposes to separate the minus 5 from this expression here. Okay, that's x and then plus minus 5. It's technically the same thing as having x minus 5. And again, that plus x that we have here is just for separation purposes. Okay, so let's begin. So I'll do the same thing. I'm going to begin multiplying each term from my height by each term from the base. And what that means is that I'll multiply 3x to the power of 3 times 2x to the power of 2, and that will be my top left entry in the area. Then after that, I'm going to multiply 3x to the power of 3 times the middle term on the base, which is 2x, and that will be the middle term at the top of this section. And lastly, I'm going to multiply 3x to the power of 3 again, but now by the last element of my base, which is the positive 3. and that will guarantee this section right here. And as you can see at this moment, the next process will be to multiply the x from the height times each term on the base, and those answers will be aligned in the middle section in these three boxes inside the rectangle. The last step will be to multiply the -5 times each element from the base. That will guarantee the last three entries down here in the rectangle. So I'll begin multiplying. So if I multiply 3x to the power of 3 times 2x to the power of 2, I'm going to get 6x to the power of 5. Then we multiply 3x to the power of 3 times 2x, which is 6x to the power of 4. Then we multiply 3x to the power of 3 times 3, and that'll be positive 9x to the power of 3. Okay. Next, we multiply x times 2x to the power of 2, which is 2x to the power of 3. X times 2x will be 2x to the power of 2. And x times 3 will be positive 3x. Last row. -5 times positive 2x to the power of 2. That'll be negative 10x to the power of 2. -5 times 2x, that will be negative 10x. And then -5 times 3 will be negative 15. Now, I made a quick amateur mistake, which is we do not recommend that we use x as a multiplication symbol when you're working with variables, because you can get them mixed up. So instead, I'll be using the dot symbol, which means we're multiplying. A second. There you go. Which means we're multiplying the base times the height. There you go. Okay. And then the last step will be to add all the terms that we have collected inside the area. So I'm going to be adding the 6x to the power of 5 plus 6x to the power of 4 plus 9x to the power of 3. That's the first row. And plus 2x to the power of 3 plus 2x to the power of 2 plus 3x. And the last row will be minus, you can put a plus, minus x to the power of 2, and then a plus another negative 10x, and then lastly plus a negative 15. Okay, so now at this point we have all the terms that were multiplied and are representing the answers here from this multiplication problem. All we have to do is identify any potential like terms that we can add or subtract, and that will guarantee the answer for this problem. So if you notice, to find any like terms, we have to technically just group all the terms that have the same variable and the same exponent. So I'm going to be hunting those terms that satisfy those conditions. So if you notice, we have 6x to the power 5 as the only term that has that exponent, which means that this one will be a lonely term that we can just include right here because it doesn't have any other like terms. And also, if you notice, this 6x to the power 5 is the only term that has the same variable and exponent. So that's going to be another lonely term that we can't possibly group because that doesn't have any like terms. But then it gets interesting because if you notice, we have these two terms that have the same variable and the same power, which is 3. So we're going to add them. We're going to add 9x to the power of 3 plus 2x to the power of 3, which is in this case 11. Positive 11x to the power of 3. Okay, this one is done. And then if you notice, I have this 2x to the power of 2, and I have this negative 10x to the power of 2 that can also be combined. So in this case, if you add 2x to the power of 2 plus minus 10x to the power of 2, they're going to end up subtracting. So and the answer will be this negative 8x to the power of 2. Okay, now with this one and this one. And then now we have this 3x that has the same variable as the negative 10x. So that makes them like terms. We have a 3x and then plus this negative 10x. They're going to subtract as well. One is positive, one is negative. When that happens, we get this negative 7x. And lastly, ladies and gentlemen, we have this negative 15, which does not have any other like terms. And this right here is the final answer. Yeah. So this works for any type of multiplication with any type of dimension. You can multiply an expression that has a polynomial with 5 terms times an expression that has a polynomial with 3 terms. You can multiply any one that has 10 terms by any other one that has 2 terms. It doesn't matter. The point is that this visual representation, ladies and gentlemen, is going to work every single time. Okay, it's visual, it's straightforward. Yes, it takes time, but conceptually speaking, it makes a lot of sense. I hope this video helps. Have a wonderful day, and this is Math to the Point, ladies and gentlemen. Take care.